So I found a great question for you. It's another distance, speed, time question. But I want to read this with you. Look, Bill and Kate decided to go on a canoe trip. Great. They paddled 8 kilometers upstream against the current. So the current is working against them, which means they're going to go a little bit slower. But then they return downstream. And you got to remember, if you're going with the current, that means the current is pushing the boat along. Okay, the entire trip upstream and downstream, this is important, took exactly 3 hours. Interesting. Now, I also told you in this question, if the current was determined to be 2 kilometers per hour, determine okay? Now, what does this mean? That means when you're going upstream, that 2 kilometers an hour is working against you. When you're going downstream, that 2 kilometers an hour is pushing you downstream, making you go faster. So now let's start looking at this question again, and we'll fill out this table. Here we go. Okay, so what distance do they travel? Well, they traveled 8 kilometers upstream. Okay, upstream. And they did the return trip, which is downstream. Okay, so they traveled 8 kilometers downstream. Yippee skippy, that wasn't that tough. But did they tell you what the speed they were paddling at? No. So the speed that you're paddling at was just S, but you're going upstream, right? So upstream sits right here against the current. You're going against, so that current is working against you, so that's why it's a -2. And if you're going downstream now, that current is working for you. So your speed, whatever your speed was, you have to add the current to it. There's +2. Now think about it. What did the time take? I don't know. The time was different for each one of them because this was time going upstream, you're going slower, and this was time going downstream, you're going faster. So these two times are going to be completely different. But here's the cool thing. Your entire trip upstream and downstream took exactly 3 hours. So these two together, right? T up plus T down took exactly 3 hours. Interesting. Well, guess what, folk? That is the link. That's the link that's going to tie all of this together for us. Interesting. Okay, so how's this going to work? Simple. This is a DST question. You know it's a DST question, and I purposely wrote it out as distance, speed, time like this because that tells us what the formula is. The formula is distance equals to speed times time. But what I'm saying here is since this is the big hint, why don't you look at this upstream and downstream and let's convert this into times? Because we know the time up and the time down is 3. That's the big hint on this question. Okay, so if we convert this into times, let's look at the formula. So if distance equals to speed times time, what is time equal to? Well, simple. All you got to do is subtract the s from both sides, right? Cancel that out. T is distance over speed. And guess what? You have that. There's the distance. There's the speed. Now you can find the time up. There's the distance for this one. There's the speed for this one. You can find the time down. Add them together, and you know that equals to 3. So we're almost done. Isn't that amazing? Okay, watch this. So let's do this. Time up plus time down has to equal to 3. All right. Okay. Upstream, there's your distance, 8. There's your speed, s minus 2. Oh my gotcha, there it is. Now look, time down is the same distance, 8, and s plus 2. And those two times together is going to give you 3. But look, I'm writing the 3. I know that this is going to be a rational expression, which means it's a fraction. So I'm going to write this as a fraction. Oh my goodness. This is so easy from this point on. And one of the reasons why it's going to be easy is because you got to remember and ask yourself that question that we always ask ourselves when we're making common denominators in rational expressions. What's missing? Look, this has got an s minus 2. This has got an s plus 2. On this guy, what's missing? Well, of course, it's missing the s plus 2. And what you do to the bottom, you do to the top. Right? Look at this guy right here. What's it missing? Well, this is missing an s minus 2. There's your s minus 2. Look at that. What's the 1 missing? It's missing both, S plus 2 and S minus 2. Cool. So make sure you put that in the numerator as well, because remember, when you're making your common denominator, what you multiply the denominator by, you multiply the numerator by. Now, before we cancel this in solving, let's figure out what S cannot be. Non-permissible values, NPVs. So S cannot be 2 and minus 2. So there's the 2, there's the minus 2. Or we could just put down plus or minus 2. Now, I want to spend like 10 seconds here talking about why S can't be equal to plus or minus 2. Think of the scenario you're in. You're canoeing. You're going a distance, you're going a speed. What if this speed was here, plus 2? What if it was plus 2? 2 minus 2 gives you a speed of 0. Are you going to travel any distance when you're not going anywhere? Think about it. If your speed is 0, right? Can you go anywhere? No. That's why that's a non-permissible value. Same thing goes with this one. Look, if our speed was -2, and think about it, -2 means you're paddling backwards. Duh. Okay. -2 plus 2 gives you a speed again of 0. If you're going a speed of 0, you can't go anywhere. You're stuck. You're not going to make that 8-kilometer trip, not moving, right? So that's one of the reasons why these guys are so important. Okay. Now, let's go back to the problem. Now that we got the common denominator, now that we know what the NPVs are, it's gone. But look what it's leaving with. Check this out. Oh, let me just move this back a little bit. There we go. Okay, check what this is leaving us with. Don't forget, distribute. You have 8S plus 16 plus distribute. 8S minus 16. Oh, wait. We got to FOIL that. That equals to 3 S times S, S squared. S times minus 2, minus 2S. 2 times S plus 2S. And then finally, oh, look at that. That's minus 4. But wait a second. Let's clean this up a little bit, right? Minus 2S and 2S, they cancel. Why? Because think about this. Isn't this 3S squared minus 4, which looks an awful lot like, yep, difference of squares. Right, the S minus 2S plus 2. Isn't that called a conjugate? Yeah, I know that's from the other unit. And you're going, no, you can't do that, sure. Well, guess what? I just did. Okay, look on this side. Let's combine 8S and 8S. 16S. 16 and minus 6. Oh, how pretty. Those are gone. Okay, let's clean it up some more. Let's distribute this. Woohoo! I got 3S squared minus 12 equals to 16S. Now, how do you solve something like this? Really simple. Bring it over to the other side, right? Subtract 16S from both sides. Subtract 16S from both sides. That's gone, leaving you 0 equals to 3S squared minus 16S minus 12. Yep. Now, the cool thing about this is we'd like to go out at this point and just divide out that leading coefficient to 3. But guess what? 3 doesn't go into 16. Dagnabbit. So guess what? Yep, there it is. PSA. There it is. How pretty is that? 3 times minus 12? Minus 36. Minus 16. Two numbers together to multiply to give me minus 36. That add up to minus 18. So you got, oh, think about it. That's minus 18 and 2. Look at that. Minus 18 plus 2 works perfectly. So let's PSA this properly. Okay, 3S squared minus 18S plus 2S minus 12. Oh, everybody's favorite. Starts with G, rhymes with group factor. That's right, group factor it. Wow, you guys figured that one out. 3S, S minus, S minus, what is that? That's S minus 6, of course, okay? Take out a 2. That'll give you with S minus 6, and lo and behold, they match. Yay, S minus 6. What's left? 3S plus 2. And remember, all of this equal to our pal over here, 0. which allows us now to solve. This is s minus 6 equals to 0. We have 3s plus 2 equals to 0. Bring the 2 over. There's 3s equals to minus 2. Divide by 3. Divide by 3. S equals to minus 2/3. What? You can't go backwards. What's the point of going on a canoe trip and canoeing backwards? That's just kind of silly. Okay, let's go over to this side. Add 6, add 6. That's gone. S equals to 6. And lo and behold, there's your speed. Remember, S stood for speed, and that's 6 kilometers per hour. How incredible. Now, let's take that S equals to 6 and go back to our original question and start answering some of the questions. Okay, so we're back here. Now, think about this for a second. What is their actual paddling speed? The speed in still water. That's without the current. Well, we just figured that out. That was S, and we found out S to be 6 kilometers per hour. Oh, how nice. So, okay, so let's figure out the speed going upstream. If we put a 6 in here, look at this. Wouldn't that be 6 minus 2? So they're actually going upstream against the current at 4 kilometers per hour. Same thing goes with this S here. Let's put in the S of 6. 6 plus 2 tells me with the current, they're going downstream at 8 kilometers per hour. Well, now that we know the speeds, we know the distances, we can figure out the times, no problem. Okay, look, remember distance, or I should say time, was right here. Distance over speed. The distance was 8. The distance is 8. Over a speed, we figured out to be 4. Look at that. 8 divided by 4, that's 2 hours. Oh my goodness, to go upstream against that current, it took us 2 hours. Wow. Okay, so let's figure the downstream. Think about it. Going downstream, still 8 kilometers, right? Let me get a little bit more room here. Let me get rid of that start. There it is. It's still 8 kilometers, but look at this. Our speed was 8 kilometers per hour. 8 divided by 8. Oh my goodness, that's just way too easy. That's 1 hour. And lo and behold, look, 2 hours plus 1 hour gives us, guess what? Our total time, which was 3 hours. Isn't that neat how all of this works out? So actual paddling speed, 6 kilometers an hour. The time it took to go upstream, time it took to go up, 2 hours. Time to go down, 1 hour. Beautiful. Look how that works. And the most important thing here, ladies and gentlemen, it was all based on the fact that you were given T up and T down is 3 hours, and you work the equation from there. What a great question.